Hello everyone. So in this session, we are going to discuss about the autoencoders and GAN overview as the part of the unsupervised deep learning. Let us continue this. Actually, in your syllabus, we have the GAN as the part of the unsupervised deep learning. And autoencoders are also mentioned in that, but in the syllabus and the textbook, it was not mentioned clearly, but we have the lab exercise. So because of that, I'm going through the architecture. Now, already we know that CNN, convolutional neural network. So in the convolutional neural network, what we are doing is, we are taking some image and adding some convolutional layers and subsampling, and there may be the combination of subsampling, convolution, and of course if you want the batch normalization, all these the combinations we can use, and finally we will go with the flattening layer. After that flattening layer, we are connecting to the dense layers. After the dense layers, we are applying the softmax to classify the categories. So in this example, 2 is the given input, the image, and it will be classified as the 2. So this is our regular CNN. Now my idea is, I don't want to discriminate. Actually, this is the discriminative model, meaning that we are discriminating, meaning that we are finding the category of that particular image. Now I don't want this category separation, category identification. I want to generate the new image from the existing image. How can we do that? So for that, we have to change the architecture little bit. So we are taking the architecture whatever we have taken for the classification, that is like the convolutional layers, combination of convolutional, and of course we can use the pooling layers and others, and then finally we will get the dense layer. After the dense layer, what we are doing is we are regenerating. We have to regenerate the image, meaning that we can make the mirror effect. We can simply say that we can create the mirror effect of the previous layers on the other side, so that we can regenerate the image. Now in this, what we have to observe is the middle one. This is the representation vector. We can represent that with H. The representation vector, this entire image will be represented in this small vector. In this case, its size is 10 only. So from that representation vector, we can regenerate the image by using the deconvolution concept. That can be also called the transpose convolution. Okay, so we can achieve this by using two methods. One is the deconvolutional layers, that is the transpose layer, or by using the upsampling, combination of upsampling and regular convolutional layer. So we can use any one of them. So here we have two networks. One is to create the representation vector. Another is to create the image, regenerate the image. The network which is using for creation of the representation vector, that is called the encoder, and other network which is regenerating the image, that is called the decoder. So this is the combination of the encoder and decoder networks, that is the autoencoder. Now if you want to generate this autoencoder, we have to understand that autoencoder, it is the combination of encoder and decoder. Encoder network, it will convert the image into low dimensional representation vector. So we can say that this is the representation vector, and decoder network, it will regenerate the image. So actually this representation vector can be also called as the latent space. So in the latent space, we will use the representation vector, a small vector which is representing the entire image. So, and now the encoder, how can we implement the encoder? It is like our regular neural network concept only. So we are just specifying the z dimension. Z dimension is the representation vector. We can say that is the representation vector is 100 I am taking. So we are taking with we are creating, see here, encoder, we are taking that as a sequential. We are adding the layers one by one, convolutional 2D and ReLU activation, and then batch normalization, conv2D batch nomination, conv2D batch nomination, where we are having that. Finally, we are going with the flattening layer and then dense layer with the representation vector size and the activation is relu. So we generated the representation vector. So to connect this, that can be represented in the picture form like this. We can generate this by using the plot model in the TensorFlow. Okay. Now we can go with the decoder. The decoder is the reverse operation. It is taking that Z, that 100 elements we have taken here in this example. So that will be taken, and that from that we have to regenerate the image, so that we are using the conv2D transpose. There we are using the conv2D, here we have to use the conv2D transpose to regenerate the image. So here, this is the network. We are going with the regeneration of the image by using the conv2D transpose 1, 2, 3, 4 and so on, number of networks, and of course we are using the batch normalization, the middle layers. And then we can generate the autoencoder by combining these two. See here, autoencoder equal to sequential, autoencoder dot add of encoder, and then dense of representation vector, and then add of we are reshaping that representation vector into the deconvolutional layer, meaning that the decoder, and then adding the decoder and summary. So as a summary, we are using the input vectors, input image, and going with the encoder layer. This is the sequential, it is an encoder layer, and then we are going with the dense layer and then reshaping. After that again we are having one more sequential. This is the decoder, encoder and decoder combination. So this is the autoencoder concept. Now by using this we can generate some images, but there are some restrictions for this. We cannot generate the high quality pictures. We can generate some pictures, but we cannot generate the high quality pictures like this. See here, you can see that you may assume that these are some celebrities, but all these are the generated images, GAN generated images. Okay, so we have to go with the generative model, that is called the generative adversarial network. This is the next level of the autoencoder. So it is the way of training the generative model by framing the problem as the supervised learning problem with the two subnets. Actually we can call it as the unsupervised, because it is looking like the supervised, but it is following the unsupervised, because we don't have the target image. Without knowing the target image, we are generating one image, and of course we are generating and we are comparing with some other images. So it is called the supervised as well as the unsupervised also. We can say that it is the semi-supervised. So it includes both. So here there are two networks. One network is to generate the images. Another network is to differentiate that image from the other images. So these are the two networks we are using. Now this is the model for generative adversarial network. Now in this, in between the autoencoder and the GAN, there is another concept that is called variational autoencoder. As we have seen, an autoencoder is having, in the middle we are having some representation vector. That representation vector is also called the latent space, and that latent space can be generated with two vectors. One is the mean vector from the image, another is the variance vector. Mean vector and variance vector, we are taking two vectors and we are combining them to generate the latent space. Meaning that here we can take some random values and we are generating, but still we are regenerating, we are taking the representation from the existing image only. So that variational autoencoder, it can solve some problems of the autoencoder and it can generate the images. Now I want to go with from the variational autoencoder to GAN. So in this case, we can say that we are having this. See, whatever we are having, the generator part, the decoder part, that was separated, and it is separated, and also we are having the latent space. Along with the latent space, we are taking that into a separate network. And now in this way, only we are having this network, the top network, that is given only for classifying whether the image is real or fake. Fake images are generated by the generator. This is the generator network, this decoder, and it is called the generator here, and that can be represented with the top model, that network is representing to classify whether it is a fake image or real image. So see here, there are two images available. One is this one is the real image, and this is the generated image. We will give these two as the input to this. If you see this here, we can consider this. These are the real images, and this is a generated image or fake image, and these fake images also given as the input to the real images. And now if you want to train this model, we have to train the model two times. One is for the discriminator, second one is the generator. Discriminator will discriminate, meaning that classify whether it is a fake or real, and the generator, it will generate the realistic images based on the feedback by the discriminator. So see here, to train the discriminator, we have to go back with the cross entropy. We can use the cross entropy. Generally it is the binary cross entropy, and we can say that this network will take the real images as well as the images generated by the generator. These two images will be taken by the discriminator, and it will classify whether it can classify or not properly. Fake images should be classified as the fake, real images should be classified as the real. Now the generator has to be again checked. Here latent space means here we will take the random values, that is the noise. Purely noise we will take, and we will generate the image. Randomly we will generate the image. Obviously it will give that as it will be identified as the fake. Now the generator will be trained. The generator will be trained to create the realistic images which can cross the discriminator test, meaning that it will try to generate the images which the discriminator can find that as the real image. So it will try to generate in that level, and discriminator, it will always try to predict the new one, always try to predict whether it is a real or fake. So these are the two networks trained together. For some time it will train the discriminator, and sometimes it will train the generator. The generator training is the most important. Of course, discriminator after generation of the images. Let us say, for example, first time if we are getting the completely blurred image, and obviously the discriminator can classify. Now the generator is getting trained, and it is already trained, and it can generate the realistic image, so that the discriminator cannot be identified. It cannot identify whether it is a fake image or not, so that it can be recognized as the real image. Now at this time, all the fake images are identifying as the real images. In this situation, we have to train the discriminator again to classify that this is the wrong image, this is the fake image, this is the right image. So we have to train this model again, discriminator model again. So sometimes we have to generate we have to train the discriminator, sometimes we have to generate the generator. So based on this, the entire process will be continued. Now this is a small example to represent this fake note printing. So see here, the generator, this is the generator, this is the discriminator. The fake note generator, meaning that the printing will be done something, and the discriminator, it will be always trying to check whether it is the real or fake discriminator. So based on the feedback by this, so it is real, it is identifying that as the fake, so that we have to we have to train more, and we have to generate again this image. So what it is taking, you can observe that there is the noise, only raw material it is taking and generating. So based on this, it is generating the images, and discriminator is always trying to catch that. After some time, the generator can generate the realistic images, and the discriminator will be confused, and it will find that fake image as the real. Now the discriminator again train. This is the process. Now already I have shown that, and this is another example. It is taking the random noise. Generator is taking the random noise and generating. The discriminator is taking the training set from the realistic images, real images, and fake images as the input, and it is classifying real or fake. Now, how can we train the model? How can we, what are the components? Generator, discriminator, and loss function. Loss function is also important here. Now, the generator training is, it involves the components of the generator and discriminator also. But while training the generator, the discriminator weights will be locked, and only the generator weights will be updated, and it will be locked, so that only the generator will get trained. Okay, and while training the discriminator, we will consider only the discriminator part, and the discriminator will be, the weights of the discriminator will be updated. So back propagation will be applied on the discriminator and generator separately, so that discriminator trains one or more epochs, and generator will train one or more epochs and repeat these steps number of times. So please remember that while training the generator, the discriminator should be locked. Otherwise, the discriminator will be trained wrongly. So that we have to lock it. So loss function. Loss function, we have to create the loss functions. We have to use the loss functions for generator and discriminator. So that, see here, that we have to use the loss function for the generator and discriminator separately, and we have to add these two. So this we can go with that. And applications, there are several applications are available. Now we can generate the examples for the image data sets, generate the photograph or human faces, realistic photographs, cartoon characters, style transfers, and different kinds of applications are developed. Now, if you want to implement the generator and discriminator model, meaning that GAN model, we have to normalize the images, take the images and normalize the images, and create the generator discriminator network, and loss function we have to define. After that, we have to train it. So that this is the simple code, sample code we have given. This is for the generator model. If you observe that everything is the convolutional layers only, convolutional neural network only, and then discriminator is also having the similar thing, and by combining them there will be a little difference, meaning that we have to define the loss function, discriminator loss, generator loss. Here we are generating the discriminator and loss generator loss functions. After that, we are going with the final optimizer. We have to create the optimizer for the both generator and discriminator. So we are taking Adam here, and of course, if you want to go with, you can use this model. That is, it is in my Kaggle account. You can directly go with that. And then types of GANs. There are various types of GANs: standard GAN, conditional GAN, and deep convolutional GAN. This is what we discussed till now, because we are using convolutional neural network, deep convolutional neural network. So it comes under DC GAN and WGAN, VAE GAN, and the cyclic GAN. These are the various types of GANs available. Cyclic GAN, I am just showing the figures. See here, we are taking this figure and this figure. This figure will be converted into this. This figure can be converted into this, meaning that if you take the zebra, that will be converted as the horse. If you take the horse, that can be converted into zebra. So if you take the art, a painting, that can be converted as a realistic photo, and if you take the photo, that will be converted as the painting. So like this, there will be the conversion of the images from here to there, vice versa. So you can observe that this is the very interesting thing. See here, we have the horse and the zebra. You can observe that horse is converted as zebra. So this is all, these are the various types of GANs, and we can go in detail at some other time. So here I am going to conclude this session. So we can use the GANs to generate the images, and advanced models. If we combine this concept with advanced models like LLM, we can design more realistic images, and we can achieve something more. and that is called the vision language models, VLM. So thank you.